Hello everyone, this is another video on differential equation. Okay, we had discussed differential equation in previous session, so we'll continue that discussion here. So in this video, we'll be discussing linear second order differential equation. Linear second order differential equation. Okay, so what will be the general equation? D square y by dx square plus p dy by dx. Okay, plus qy is equal to 0. Hmm. So if m1 and m2 are real and unequal, y is equal to c1 e to the power m1x, c2 e to the power m2x. Okay. If m1 and m2 are real and equal equal, that is m1 is equal to m2 is equal to m, then solution will be of the form, then solution will be of the form solution will be of the form y is equal to c1 plus c2x into e to the power mx. Okay, c1 plus c2x e to the power mx. This is the second. The third one is what? If m1 and m2, if m1 and m2 are complex numbers. Just a second. If m1 and m2 are complex numbers, solution will be of the form c1 m1x, c2 m2x. Okay, we'll just put the values, the complex numbers here. Okay, last one is if m1 and m2 are complex conjugate of each other, that is m1 m2 is equal to alpha plus or minus I beta, and solution will be of the form y is equal to e to the power alpha x a cos beta x plus b sin beta x. Okay, just a second. Give me a minute. Still some problem. Can you write a question? First question. So solve d square y by dx square minus 7 dy by dx plus 12 is equal to 0. So how to solve it? In place of dy by dx, you will put m. Okay. Can write as d square minus 7d 12 is equal to 0. It can be written as m square minus 7m 12 is equal to 0. M square minus 3m minus 4m plus 12 is equal to 0. So m all into m minus 3, 4 minus m minus 3 is equal to 0. Okay. M is equal to 3, m is equal to 4. Yeah. M is equal to 3, m is equal to 4. So how what is the solution? Y will be c1 e to the power 3x, c2 e to the power. Okay. Is that alright? Yeah. Next question number 2. dqy by dx cube minus 8y is equal to 0. So this is mq minus 8 is equal to 0. So this is like what mq mq is equal to, so m is equal to 2 2 2. So I can write y is equal to c1 plus c2x plus c3x square e to the power 2x. Okay, got it. Otherwise, there is another way to solve this question. dqy by dx cube. Some books you can find this one also. mq minus 8m is 8 is equal to 0. So m minus, this is mq minus 2q. So aq minus bq formula is a minus b whole into a square minus ab plus b square. So a square plus ab plus b square. So this will become m minus 2 m square plus 2m plus 4 is equal to 0. Yeah. So m is 0. M square plus 2m plus 4 is equal to 0. So m is equal to 2. One value is m is equal to 2. Another one is m square plus 2m plus 4 is equal to 0. M is equal to minus 2 plus or minus b square minus 4ac. The 4 into 4 divided by, so minus 2 plus or minus 4 minus 16 by 2 minus 2 plus or minus root over of minus 12 by 2 minus 2 plus or minus 2 root 3 I divided by 2. Okay, that is minus 1 plus or minus root 3 I. How to do this? How to do, write the solution of this? This solution is easy, like what? E to the power alpha x, that is minus x, a cos beta x, that is root 3x, plus v sin beta x, that is root 3x. Is that all right? Hmm? Okay, that will be the way to solve this question. Yeah, that's correct. Another one, term was c1 e to the power 2x. Yeah. Next question, question number 4, I think, 4 3. d square, sorry, t square plus. Okay, wait, these questions are easy. Okay, let me write this question. D square y by dx square plus 2p dy by dx plus p square plus q square y is equal to 0. Hmm? So what is the solution? Okay, again, see, m square plus 2pm plus p square plus q square is equal to 0. So m is equal to minus 2p plus or minus b square, that is 4p square minus 4ac. 4 into p square plus q square, right? Divided by 2. 2a is 1. So minus 2p plus or minus, so minus root over of, that will give me minus 2p plus or minus minus root over of q square by 2. Hmm. Otherwise, we can do one thing. If this way is not correct, then let me write the equation d square y by dx square plus 2p dy by dx plus p square plus q square y is equal to 0. M square plus 2pm plus p square plus q square y is equal to 0. M square plus, I can write 2p as p plus q plus but that is not going to give me p square plus q square. The question, okay, then I think the question is wrong. Question should be minus b. Okay, hmm, yeah, minus should be there. So this one will become p plus q plus p minus q whole into m p square minus q square y. Okay, if you take the common, so this one will become m plus p plus q, m plus p minus q is equal to 0. M plus p plus q whole into m plus p minus q is equal to 0. So m is equal to minus of p plus q, m is equal to minus of p minus q, which is in fact q minus p. Okay, so yeah, we just write the solution. Y is equal to c1 e to the power minus p plus q x plus c2 e to the power, don't forget x, okay? U minus b x. Alright? Yeah. The next question, question number 5. Consider the differential equation dqy by dx cube minus 3 du square y by dx square is 2 dy by dx is equal to 0. It's given that d square y by dx square is equal to 1, dy by dx is equal to 0, and y is equal to 1 and x is equal to 0. Then the value of y at x is equal to 0, x is equal to 2 is nearest to. Okay, so let's write the equation m cube minus 3m square plus 2m is equal to 0. M over into m square minus m square minus 3m plus 2 is equal to 0. So m square minus 2m minus m plus 2 is equal to 0. M1 to m minus 2 is 0. So m is 1 and m is 2. Okay, so the y will be what? Okay, let's write it on the page. Y will be c1 e to the power x plus c2 e to the power 2x. Okay, what is also given in the question? D square y by dx square is equal to 1, dy by dx is equal to 0 when, and y is equal to 1 when x is 0. So let's put x is 0 here and y will be 1 plus c2. This is one equation. Now dy by dx will be c1 e to the power x plus 2c2 e to the power 2x. So dy by dx is 0 when x is 0. 0 is equal to c1 plus 2c2. That is equation 2. Okay. If we subtract equation 1 and 2, we will get 1 is equal to minus c2. So c2 is equal to minus 1. Right? Mm. c2 is equal to minus 1. And c2 is equal to minus 1. I made a mistake. Sorry. I made a mistake. Wait. Here, m should also be 0. Na? This m should be 0, right? So the whole solution is wrong now. So there are three solutions. M is equal to 0, m is equal to 1, m is equal to 2. So y should be c1 e to the power 0x plus c2 e to the power x plus c3 e to the power 2x. c1 plus c2 e to the power x plus c3 e to the power 2x. Okay. Now y is equal to 1 when x is equal to 0. 1 is equal to c1 plus c2 plus c3. Equation 1. Y dy by dx is equal to 0 when x is equal to 0. So let's put let's calculate dy by dx, which is equal to c2 e to the power x plus 2c3 e to the power 2x. Yeah. So this is 0 when x is 0. C2 plus 2c3. So this is equation 2. Another equation is there also. D square y by dx square is equal to how much? 1 when x is equal to 0. Yeah. So what is d square by? First of all, y is c1 plus c2 e to the power x plus c3 e to the power 2x. dy by dx is c2 e to the power x plus 2c3 e to the power 2x. D square y by dx square is c2 e to the power x plus 4c3 e to the power 2x. So this is 1. 1 is equal to x is 0. c2 plus 4c3. This is another equation. 3. What are the equations then? c1 plus c2 plus c3 is equal to 1. Okay. c2 plus c3 is 2c3 is 0. Okay. c2 plus 4c3 is equal to 1. First let's carry out this 2. So if I subtract it, 2c3 is equal to minus 1. Minus 2c3 is equal to minus 1. c3 is equal to 0.5. Now I put it here. c2 plus 1 is equal to 0. c2 is equal to minus 1. Put it here. c1 minus 1 plus 0.5 is equal to 1. 2 to 1.5. c1 is 1.5. Yeah. So uh, the value of y at x is equal to 2. First, let's write the solution then. Solution will be y is equal to c1 plus c2 e to the power x plus c3 e to the power 2x. And that means c1.5 plus minus e to the power x plus 0.5 e to the power 2x. Yeah. So value of y at x is equal to 2. So x is equal to 2, put it 0.5 into. That's it. Just have to calculate. E is 2.71 something. Just have to put it here and calculate the values. Right? I hope you can calculate this. Uh, okay. Next we'll study about particular integral. Non-homogeneous differential equation. Particular integrals. So write down. First formula is if okay. First of all, I'll write the general is d square y by dx square plus p dy by dx is q y is equal to r x. So you can write as d square plus pd plus q is equal to rx. Hmm. So So we can write it as f of d y is equal to x. So suppose first one is if Rx, this Rx, okay, is equal to e to the power ax, then particular integral uh, is 1 by f of d e to the power x, that is, just you have to put this a in place of d, 1 by f of a to the power x. Suppose this f of a is 0, then thing won't be defined, right? If so, what will happen? F of a is 0, what will you do? Particular integral will be, what will be the particular integral? You have to multiply x, and in the denominator you have to take the derivative of f of x, f of d, and put the value again. Okay? If f dash is also 0, this one is also 0, it will just go on like this. Okay, x, another x multiplied by f double dash a e to the power x, it will go on like this. Alright. Next, number two, if Rx is a polynomial of x, particular integral will be how much? 1 by f of d is to the power n. Okay, what do you have to do here? Expand f of d. Expand 1 by f of d in series containing positive powers of, okay. Number 3, Rx is equal to cos ax or sin ax. Particular integral will be from d square sin ax for minus a square sin x. Okay, you just have to put a minus here and put the value of a. D square cos ax equal to 1 by f of minus a square cos ax. Okay, yeah, yeah. For example, this is 0, then what will you do? Again, same thing. If dash minus a square is 0, what will you do? You just multiply x by, take the derivative of this one, cos x or sin x, whatever will be there. Okay, yeah. Last one, number 4. Number 4 will be if Rx is equal to e to the power ax phi x. Okay, e to the power ax phi x, then particular integral will be how much? 1 by f of d e to the power ax phi x, that will be, e to the power x will come out, uh, 1 by f of d plus a, it will be, this a will be added here, alright, into phi x. This is an important one, remember this one, question come from here, this one. Yeah, yeah. Still numericals. Question number. What is the question number here? 7, I think, or 6, 6. D square y dx square. You just calculate the particular integral. Okay, no need to calculate the complementary function like the first one we studied because that is easy part. So let's do the particular integrals. So here for particular integral we'll calculate m square. So d square minus d minus 2 y is equal to sine 2x. Isn't that? Isn't it? So particular integral is how much? 1 by d square minus d minus 2 sine 2x. Yeah. So for sine, if you see 1 of f of d square sine 2x would be how much? 1 by f of minus a square sine 2x. Yeah. So 1 by minus 2 square by minus d minus. Don't put in place of only d. If only there is d square, then only we'll put it. Okay. Not in place of d. So this one will be what? Minus 4 minus minus 6. So minus d minus 6 sine 2x. So if I write it again, minus 1 by d plus 6 sine 2x. Yeah. So multiply. Now we need square term. For calculating sine and cos, we need a square term like d square. D only won't work. So what will I do? I will multiply d minus 6. D minus 6 both numerator and denominator sine 2x. So minus of d minus 6 divided by d square minus 36 sine 2x. Okay. Now what? Again the same thing. Alright. Again the same thing we have to do. But see different. There is a bit of difference. First, d of sine 2x by d square minus 36 minus 1 plus 6. This one is d square minus 36 sine 2x. So here first we have to do the d of sine 2x. And that means derivative. D means simply derivatives. Derivative sine 2x is how much? 2 cos 2x. So minus of 1 by d square minus 36. I'll just write it as 2 cos 2x plus this one plus 6. This is 2. So I will just put here minus 2 square, not minus 2 whole square, minus 2 square sine 2x. Okay. Now what? Now minus 1 by d square minus 36. 2 will come out cos 2x plus plus 6 minus 4 minus 36 sine 2x. Yeah. And that will be here again minus 2 1 by 2 square minus 36 cos 2x minus 6 by 40 sine 2x. That will be minus minus plus 2. This will be 40 to 20 1 by 20. Okay, I did it very fast. You just I hope you can do it also. 3 by 20 sine 2x. Alright. Yeah, this was the answer. Only by calculating particular integral, a complementary function you can easily calculate, no problem. Okay, next question. Question number 7 or 8. I think 8. Whatever. D square minus 2d plus 1 y is equal to x square e to the power 3x. This comes in the form of what? E to the power ax 5x. What was the particular integral for that? E to the power ax 1 by f of d plus a 5x. Yeah. So let's do it. So particular integral is equal to um, sorry, yeah, 1 by d square minus 2d plus 1 x square e to the power 3x. 3. That is equal to e to the power 3x. 3 1 by d plus a, that means d plus 3 whole square minus 2 d plus 3 plus 1 x square. So it is about 3x 1 by d square plus 9d plus, sorry, 6d plus 9 minus 2d minus 6 plus 1 x square. That gives me e to the power 3x. This one will be how much? 1 by d square plus 4d plus 3 plus 1 plus 4 x square. Right? So here you can do it. How will you do this one? Tell me. Okay, this is how much? You see, this is d plus 2 whole square x square. How will it be? I have to expand this. This is a polynomial of x, so I have to expand it. So e to the power 3x 1 by d, that means d plus 2. Okay, d plus 2 whole square, let me write it again. And this is x square. So I will take 2 out hmm, before. That means 1 plus d by 2 whole square x square. So if I write it again 1 by 4 e to the power 3x, I can write this one as 1 plus d plus 2 d by 2 to the power minus 2 x square. So 1 by 4 e to the power 3x. Okay, 1 minus what will be the one? Minus 2d by 2 plus 3 3d square by 4. It will go on like this x square. So therefore it is equal 3x plus d plus 3d square by 4 x square. If you simplify it, it will 3x by 4 x square minus 2x plus 2 only here, 6 by 4 2. Okay, this will be the answer, I think. Yeah. So, yeah. Right, so this is one type of question. Expansion is a bit tricky. You have to kind of do it properly, otherwise it will be a problem. Question number 9. So here the question is d square minus 1 y uh, b cube plus 8 y is equal to x fourth plus 2x plus 1. Again, that expansion type I'm giving you. Okay. First, let's calculate the CF for it. This is a good one. Equal to 0. We had done this type, but let's practice again. 2q is equal to 0. So a cube plus b cube will be a plus b whole into a square minus ab plus b square. Okay. So a plus 2 m square minus 2m plus 4, okay, is equal to 0. So m is equal to minus 2. This m is equal to 2 plus or minus b square minus 4ac. I mean 16. 2, 2. 2 plus or minus root over 12 is 2 root 3 I. Okay, minus 2. 2 plus 1 plus or minus root 3 I. Yeah. So these are the values. One value is minus 2. So y CF will be C1 e to the minus 2x plus e to the power x a cos of 3x plus b sine of 3x. Okay, this is the CF. Now what is the particular integral? We have to find it. So again dq plus 8 y is equal to x4 plus 2x plus 1. So particular integral is equal to 1 by dq plus 8 x fourth plus 2x plus 1. Okay. So if I do it, I have to do it separately for everything. No, let me take 8 common. So dq by 8 plus 1 x fourth plus 2x plus 1. Yeah. So I can write like this: 1 plus dq by 8 to the power minus 1 x fourth plus 2x plus 1. Yeah. So 8 um, 1 by 8, I can expand it. 1 minus dq by 8 plus it will go on, but we don't need it because it's third derivative. So that much I think is required because this term will be d to the power 6. We don't need d to the power 6 for it, do we? So plus 1. Yeah. So 1 by 8. First term will be 1 multiplied with 1, so it will be same. Minus dq means third derivative of this one. 4, 4, 12, and 24, 24x. Yeah, 24x. This one is 0, 0. This is what it is. Yeah. Export. So d square 4x cube d 12x square 24x. Yeah, 24x. So if I write it again, 1 by 8. Yeah, 1 by 8 x fourth minus 22x plus 1. Yeah. Wait, am I making a mistake? Oh, by this by 8 was there now. 3. Okay, my bad. I forgot this minus 3x. So x fourth 2x minus 3x, that is minus x plus 1. That will be your particular integral. We have calculated CF. So y you can write CF plus PA. Yeah. Okay. So these are some of the questions we discussed today. Okay. I hope you understood. We will be solving more questions on this particular integral because this is an important chapter. Alright. We will also put boundary conditions and solve more questions tomorrow in the next session. Okay. Thank you very much for watching.